Okay, so let's unpack this. If you've been anywhere near, a news feed lately, you know the narrative. It's loud, it's persistent, and frankly, it's making a lot of people pretty anxious.
Oh, absolutely. The white-collar apocalypse.
Exactly. The idea that generative AI is coming for the knowledge workers first.
Right. Junior coders, copywriters.
Paralegals. The algorithm can just do it faster, cheaper, and, well, some would say better.
It's really the prevailing anxiety of the decade, isn't it? We spent 50 years telling everyone to learn to code.
And now the machine is writing the code.
Exactly.
So the assumption has always been that physical labor would be automated first, robots on the assembly line, and that brain work was safe.
But we're seeing the inverse.
We are. And we have this stack of reports here today. We're looking at the trade skills California landscape and the latest projections from the U.S. Bureau of Labor Statistics all the way through 2034. And they tell a radically different story.
It flips the script entirely. While the digital economy is, in flux, the physical economy is entering what some are calling an era of hardware scarcity.
And that's exactly where we're going today. We're looking at this one specific group of workers that the tech giants, the very companies building these AIs, are absolutely desperate for.
Yeah.
It's not prompt engineers, it's not data scientists, it's electricians.
The people who actually, keep the lights on.
So the mission for this deep dive is pretty clear. We want to figure out why, in a world that's dematerializing into the cloud, the physical premium, the value of hands-on labor, is just skyrocketing.
Right.
And we need to answer a fundamental question. Is this just a temporary blip, or is the shock-proof career actually the safest bet for the next 20 years?
Well, and to answer that, you really have to look at the intersection of three things: aging demographics, failing infrastructure, and the massive, massive power demands of AI itself.
So let's start with the baseline numbers, because I think people have this vague sense that trades are in demand, but the scale of the shortage it's actually startling.
It really is.
The BLS is projecting the electrical field to grow by, what, about 9% through 2034?
9%. And to be clear, that is significantly faster than the average for all occupations.
Right.
A lot of those administrative office support roles, they're actually projected to shrink or just flatline. So 9% is a really healthy growth curve.
But the growth percentage almost hides the real story. It was the raw number that jumped out at me.
The 81,000 number.
Yes. They're projecting roughly 81,000 openings every single year.
Right. And it is so crucial to understand why that number is so high.
Okay.
It's not just that we're building 81,000 new jobs worth of infrastructure. A massive chunk of that is simply replacement needs.
The silver tsunami.
You got it. It's a demographic cliff.
Yeah.
The baby boomer generation makes up a huge percentage of the master electrician workforce. They're retiring en masse.
Hanging up the hard hats.
They are. So you have this vacuum of institutional knowledge leaving the workforce at the exact moment that the demand for electrification is just going vertical.
So it's a supply and demand crunch? Supply is retiring and demand is exploding.
Perfect storm.
Let's dig into that demand, though, because this is where the AI paradox comes in. This was, to me, the most fascinating part of the research. We tend to think of AI as ethereal. It lives in the cloud.
We do. We think of it as just software. But the cloud isn't in the sky. It's in a building.
Right.
Usually a very large, nondescript concrete building in places like Northern Virginia or, these oddly specific patches of desert.
And those buildings are hungry.
Hungry is a serious understatement.
Yeah.
We are seeing a fundamental shift in data center architecture.
Okay.
So if you look at a traditional server, rack standard cloud computing, hosting websites, that might draw, say, 5 to 10 kilowatts of power.
Okay, 5 to 10 kilowatt, that's the baseline.
Right. Now, you look at a rack that's designed for AI training and inference.
Yeah.
You're stacking NVIDIA H100s or the next-gen Blackwell chips.
Yeah.
You are not looking at 10 kilowatts anymore. You're looking at 40, 50, sometimes pushing 100 kilowatts per rack.
Wow. That's an order of magnitude difference.
It is. And existing buildings physically cannot handle that.
You can't just plug it in.
No, you can't just plug that into a standard industrial outlet. The copper wiring would literally melt. The breakers would trip instantly. The cooling systems you need to keep those chips from frying are massive industrial projects in themselves.
So when we read about Microsoft or Google investing billions in AI, a huge chunk of that money is just trying to get enough electricity to the processors.
Precisely. In fact, if you look at the vacancy rates for data centers in Northern Virginia, which is basically the backbone of the internet, They are effectively zero.
They can't build them fast enough.
They cannot build the power redundancy fast enough. The limiting factor for the growth of AI isn't necessarily chip manufacturing anymore. It's the physical infrastructure.
Yeah.
It's the transformers, the switchgear, and the skilled labor to install it all.
So the robot revolution is currently on a waiting list because there aren't enough electricians to wire the brain.
That is the ultimate irony, isn't it? The digital world is entirely dependent on the physical world to function.
Okay, so that's the hyperscale side of things. That accounts for a specific, very high-tech sector of the trade. But most electricians aren't working in a Google data center. They're working in homes and offices. And the report brings up this concept of the electrification of everything.
This is the second driver. And this one is hitting much closer to home for most people.
Right.
Think about the average house 20 years ago. You had a 100-amp panel, you had lights, a TV, maybe an electric dryer.
Simple stuff.
Very simple. Now look at a modern, eco-conscious home. You have an EV charger in the garage. That's a huge draw. You have an electric heat pump replacing the gas furnace.
Yeah.
An induction stove. You've got solar panels on the roof, and maybe a Powerwall battery for storage.
And it's not just about drawing power anymore either. It's bidirectional, right?
Exactly. And that is a massive, massive complication. You're talking about vehicle-to-grid, V2G, or solar-to-grid systems. You are essentially turning a house into a micro-power plant.
Wow.
That requires complex load calculations. You can't just slap a new breaker in. You have to understand how that entire system balances so you don't end up blowing the transformer down the street.
Which brings us to the third driver, the grid itself. Because all these data centers and all these electric cars are plugging into a grid that, let's be honest, is showing its age.
Showing its age is being very polite. A lot of our grid infrastructure dates back to the mid-20th century.
So we're trying to push 21st century digital loads.
Through mid-century analog equipment. That's exactly right.
And the renewable aspect complicates this too, doesn't it?
Immensely. Wind and solar are intermittent. And they're often located far away from where the power is actually used.
Sure.
So you need these massive transmission line upgrades, substation modernizations, grid scale, battery storage. This isn't just maintenance. This is a complete re-architecture of how we move energy.
And every single inch of that requires licensed, skilled labor.
Every inch.
So we have the trifecta: AI, data centers, home electrification, and grid modernization. The demand is clearly there.
Overwhelmingly.
But I want to play devil's advocate for a minute here.
Please do.
Because, I've seen the videos. We all have. I've seen the Tesla Optimus robot. I've seen the Boston Dynamics Atlas doing parkour.
Car flips, yeah.
Right. If a robot can do a backflip, why can't it wire a house? I mean, is it really that much harder?
It is a totally valid question.
Yeah.
And it gets to the heart of what the source material calls the human moat.
Okay.
Why is this specific trade so resistant to automation?
Because to me, wiring sounds like a repetitive task. And repetitive tasks get automated.
And in a factory, yes, absolutely. If you are building a modular wall in a perfectly controlled environment where the lighting is perfect and the materials are always in the exact same spot, a robot can absolutely run conduit.
But the real world is not a factory.
Exactly. Let's just paint a picture here. Imagine you're an electrician. You get called to a job in a Victorian home built in, say, 1905.
Okay.
You have to crawl into an attic that's 120 degrees. It's cramped. There's insulation everywhere.
And spiders. Don't forget the spider.
That's spiders, right.
Yeah.
Now you open up a junction box. But inside that box, you have a mix of knob and tube wiring from the 1920s, some cloth-wrapped wire from the 50s, and maybe some modern Romex from a bad renovation in the 90s.
And the guy who did the 90s renovation probably didn't follow code.
Almost certainly not. Now, a robot looks at that and just sees an error message. It relies on pattern recognition. It needs predictable, clean data sets.
Right.
A human looks at that and sees a puzzle. You have to use intuition, historical knowledge of how houses were built, and tactile feedback to figure out what's live, what's neutral, and how to make it safe without burning the house down.
It's the context. The robot has no context for lazy contractor from 1995.
None. And then there's just the dexterity issue. Fine motor skills in unstructured environments are incredibly hard for robotics.
I can imagine.
Manipulating a stiff copper wire into a tiny screw terminal while you're balancing on a ladder in a dark closet. That is a level of physical intelligence that AI is nowhere near replicating.
There's also the stakes, right? I remember an old joke, dark humor really, that says, plumbers get wet, electricians get dead.
It's a morbid saying, but it highlights the reality.
Yeah.
You are working with lethal forces. You don't get a retry button on a 480-volt line. You cannot simply automate safety in an environment where the variables change every single second.
So the source material suggests that while AI might help, maybe drafting the blueprints or calculating the loads,
Sir, as a tool.
the actual execution is staying human.
For the foreseeable future, yes. The report estimates maybe 30% of tasks could be aided by technology, think automated inventory or better diagnostic tools. But the core job remains protected.
Okay, so the job is safe. But let's talk about the is it worth it factor. Because historically, there has been a stigma.
Oh, for sure.
The whole college for everyone push made the trades seem like the backup plan.
Which is a massive strategic error for the economy, but that's a whole other deep dive.
Right. But let's look at the ceiling. The median wage is listed in the low 60,000s, which is fine, but it's not exactly tech money.
Well, that's the median. And that includes a first-year apprentice and the guy who's just changing light bulbs in a warehouse.
Okay.
When you look at the specialists, the people working on those data centers we talked about, or industrial controls or high-voltage lines, the math changes completely.
How much does it change?
We are talking six figures. Easily. In major metro areas with high demand, experienced electricians in the industrial sector, especially with overtime, are out-earning many mid-level software engineers.
Without the student debt.
Usually with zero student debt,
Yeah.
because the apprenticeship model pays you to learn.
Now, the source material mentioned a specific evolution of the career that I found really interesting. They called it the AI and tech integrator.
Yes.
This sounds like the bridge between the old world and the new.
This is maybe the most exciting part of the career trajectory. We're seeing a convergence of high voltage, the power, and low voltage, the data.
Break that down for me. What does an integrator actually do?
Okay, so think about a commercial building today. The lighting isn't just on a switch anymore. It's running on PoE power over Ethernet. It has IP addresses.
Right.
The HVAC system is connected to a smart grid. The security system is biometric.
So if the breaker panel can't talk to the Wi-Fi gateway, the whole building just doesn't work.
Yeah. Exactly. The electrician of the future needs to know how to bend pipe and pull wire, of course.
Yes.
But they also need to know how to terminate a CT6 cable, configure a network gateway, and troubleshoot a communication protocol like KNX or Dolly.
So it's not just a person with a pair of pliers anymore. It's a technician with a laptop and a tool belt.
It's a true hybrid role. And because it requires that dual skill set, understanding the physics of electricity and the logic of networking, it commands a massive premium. That's where the ceiling just disappears.
It effectively shatters that stereotype of dumb labor. This is high-tech work. It just happens to be physical.
It is cognitive work that manifests physically. You're solving complex logic problems, but the output isn't a line of code on a screen. It's a functioning hospital or a running data center.
So if we zoom out and look at all this data, the national projections, it really feels like we're seeing a correction. Like the pendulum swung too far towards the digital, and now reality is snapping back.
I think that is the perfect way to frame it. We undervalued the physical world because it worked so well, we stopped noticing it. The lights just came on. The water just ran. But now that we're trying to rebuild the entire energy infrastructure of the planet to support AI and renewables, we're realizing that maintenance isn't enough. We need construction. And you cannot download a new substation.
You cannot download a new substation. That's a bumper sticker right there.
That's true.
So for the listener who might be feeling a little shaky about their current career path, maybe they're in a mid-level admin role that feels ripe for automation, or for a younger person trying to figure out a path that won't be obsolete in 5 years. What's the takeaway here?
The takeaway is to look for the shock-proof elements of any job. Ask yourself, does this job require being in a specific place at a specific time to manipulate unique physical objects? If the answer is yes, you have a moat.
And if the answer is, I do everything via Zoom and email,
then you are competing with algorithms that are getting smarter every single day.
it's a sobering thought, but it's also an empowering one if you're willing to make a pivot.
Absolutely.
Yeah.
The trade isn't a fallback plan anymore. It's a strategic choice.
I want to wrap up with a thought about satisfaction. We touched on it briefly, but the source material included some qualitative data interviews with tradespeople, and they mentioned something that I think a lot of office workers are missing: real-world impact.
It's the definition of done. In knowledge work, are you ever really done? There's always another email, another revision, another meeting about the meeting.
It's the endless treadmill.
But in the trades, there's a binary state. The circuit was broken, now it works. The light was off, now it is on. You can point to a building and say, I wired that. It functions because I was there.
There's a real psychological benefit to that tangibility.
Huge. It
Yeah.
anchors you